Hello dear students, hope you're fine. Today we're going to talk about chapter 4 section 2 atomic orbitals and quantum numbers. Okay, let's start. Quantum theory. After Bohr, scientists they developed a theory known as quantum theory. Look, we know that Bohr said electrons they spin around the nucleus in definite orbits, right? But quantum theory is about probability of finding an electron at a specific region in the empty space surrounding the nucleus and not at levels of specific dimensions as explained by Bohr. Okay, so actually scientists, after they studied about the electron, they discovered that the electrons they can behave like wave. Okay, so after that science they said electrons they don't spin around the nucleus at levels of specific dimensions. Okay, so after that they said the electrons they move like wave. Okay, so they said look at this picture, this is electron cloud. Okay, we don't know exactly where is the electron according to quantum theory, so we get a probability. Look here, look at here, probability density of electron. We get the probability density of electrons, and we say that the electron is approximately here. This is the region that the high density of electrons. Okay, so this is imagination for one electron. We don't know exactly where is it, but we get the high density of electron, this probability. Basha? So this is about quantum theory. So it's about probability finding of electron around the nucleus. So this section is about quantum theory. So we have electron cloud. The electron cloud refers to what? General area around the nucleus. I think you remember that in chapter 3 section 1 we said electron cloud is the region surrounds the nucleus where we can find the electron. So look at here, this is the nucleus, and this is the picture of electron for one electron and moves around the nucleus. You see the place that we can find this electron, it's called electron cloud. Masha? So in Bohr's atomic theory we learned that we have energy levels. This is first energy level, second, third, fourth, right? Okay. In quantum theory, we're going to learn that instead of energy levels, we have sublevels. Okay. In energy levels, we have what? Sublevels. Okay. So we have 4 types of sublevels. We can say rooms inside of what? Inside of the energy levels. Here, this is called S sublevel. We have 4 sublevels, S, P, D, F sublevel. Basha? First energy level, we have only S sublevel. Second, we have S and P. Third, S, P, D. Fourth, we have S, P, D, and F. Okay. In sublevels, we have orbitals. Orbitals in sublevels. So, for example, S sublevel contains only 1 orbital. P contains 3 orbitals. How we can make the difference between sublevel and orbitals? A group of sublevel orbitals together are called what? Sublevel. Basha, here this is P sublevel. Basha, these 3 orbitals together, they're called what? P sublevel. P sublevel contains 3 p orbitals. These squares, there are 3 squares. So these are called what? These are called orbitals. These are orbitals of p sublevel. Okay. S sublevel contains only one orbital. P, 3 orbitals. D, 5 orbitals. F, how many? 7 orbitals. In previous slide, we learned that first energy level contains only S sublevel. Second SP, third SPD, fourth SPD, F. Okay, it's written here how many orbitals does a sublevel have. Okay, where are electrons? Electrons, they are in orbitals of sublevels. Okay, each orbital can hold maximum how many electrons? 2 electrons maximum. Here S sublevel contains only one orbital. Each orbital maximum holds 2 electrons. So S sublevel maximum can contain 2 electrons. Okay, P sublevel contains 3 orbitals. Each orbital can hold 2 electrons. So we say that P sublevel maximum can hold 6 electrons. D has 5 orbitals. 5 times 2, 10 electrons. So D sublevel can hold maximum 10 electrons. F sublevel contains 7 orbitals. Each orbital can hold 2 electrons. So maximum F sublevel can hold 14 electrons. Basha. So we say that first energy level contains only S orbital. So we have only 2 electrons in S orbital. So first energy level maximum can hold 2 electrons. Second, 8. Why 8? We have 2 electrons of S, 6 electrons of P. So maximum can hold 8 electrons. Okay, third energy level can hold maximum 18 electrons. Why? 2 electrons of S, 6 electrons of P, 10 electrons of D, 18 electrons. Here, first energy level maximum can hold 32 electrons. 2 electrons of S sublevel, 6 electrons of P sublevel, 10 electrons of D sublevel, 14 electrons of F sublevel. Maximum fourth energy level can hold 32 electrons. Okay. So look at this table. This is at the end of the section. You can see that to understand this table, I have made this for you. Okay, you to understand this table. How? Main energy levels, guys. Main energy level, we know that we give the symbol which is N. Basha, energy levels, they are symbolized by what? By N. Okay, and this is N equals 2. Basha, N equals 3. What does it mean? N equals 3 means third energy level. N equals 4, fourth energy level. Basha. Main energy levels, we have 1, 2, 3, 4. We have more, but we just talk about 4 energy levels. Okay, for sub-levels in main energy level. Basha, how many sub-levels do we have in first energy level? 1. Second, look, 1 energy, 1 sub-level. Second, we have 2, S and P. Look, S and P. Third, we have SPD, SPD. Fourth, we have SPDF, SPDF. Basha. So sublevels equals n sublevel. What does mean n sublevel? Means when n equals 1, for first energy level we have only 1 sublevel, which is S. When n equals 2, we have 2 sublevels. Basha. So number of sublevels equals the number of n. Basha. Number of orbitals per sublevel. Okay, we know that S sublevel contains only 1 orbital. Again, S in second energy level also contain, because all S sublevels, they contain only one orbital. P, 3 sublevel, 3 orbitals. Look, P contains 3 orbitals. Also, it's like F, D, 5 orbitals. F, 7 orbitals we talked about. Basha. Number of orbitals per main energy level. We want to know how many orbitals do we have in each main energy level. Basha. So first we have only one orbital of S. So we have only one orbital in first energy level. Second, we have one orbital of S, 3 orbitals of P. So maximum, we have 4 orbitals. Third, we have 9, 5 of D, 3 of P, 1 of S. Maximum, how many? 9. Fourth energy level, we have 14. What? 14 orbitals. Pasha. So we can say that to find the number of orbitals per main energy level equals n squared. How? Imagine for first energy level, and this is n squared. This is the rule. Pasha. For first energy level, n equals 1. 1 squared equals what? Equals 1. So we have how many? We have 1 orbital in first energy level. If n equals 2, 2 squared equals what? Equals 4. So we have how many? 4 orbitals in second energy level. Basha? So we can 3 squared equals 9, 4 squared equals 16. Basha? Number of electrons per sublevel. We know that S contains 2 electrons. P maximum can hold 6 electrons. D 10, F 14. Basha? Number of electrons per main energy level equals n times n squared. How many electrons can first energy level hold? 2. Second 8, third 18. Look, third 18, fourth 32. Basha. We can find by a rule n 2 times n squared. Look, 2 times n squared. Instead of n, we write 2. Basha? For second energy level, how many electrons can hold? 2 squared equals 4. 4 times 2 equals what? Equals 8. So 8 is the number of electrons in second energy level when n equals 2. Okay, this is the table, and by this diagram you can understand. Let's talk about quantum numbers. Why I explained this before you to understand the quantum numbers is going to make it easier you to understand quantum numbers. Okay, what are quantum numbers? They are a set of four numbers used to describe the properties of atomic orbitals and the properties of electrons in orbitals. There are 4 numbers. We call them quantum numbers. They're going to describe the what? Energy levels, which is principal quantum number, angular momentum quantum number here, Basha, describe the sublevels, magnetic quantum number describe the what? The orbitals in sublevels. Spin quantum number is going to describe the spin states of electrons. Basha? So we're going to give them numbers. We to make the difference between them. So science, they're going to give these orbitals, sublevels, and orbitals, sublevels, energy levels, and electrons. We to understand them. Basha? So these are 4 numbers to describe the properties of atomic orbitals and electrons in orbitals. Let's talk about them. Basha. Principal quantum number, the first set of number. So principal quantum number shows the energy levels. Basha, they describe energy levels. They are going to symbolized by n. N equals what? 1, 2, 3, 4, 5, 6. The number of energy levels. Basha. Look, when n equals 1, first energy level. When n equals 2, second energy level. When n equals 3, third. When n equals 4, fourth. When n equals 5, fifth energy level. When n equals 6, sixth energy level. Basha. These numbers, they describe energy levels. They're symbolized by n. So when n increase, look at here, an electron's energy and its average distance from the nucleus increase. Basha, look, when n equals 1, when n equals 6. When n equals 6, the electrons, they are farther from the nucleus, right? So the average distance from the nucleus increase when n increase. What else? Electrons energy. We know that electrons, when they are farther from the nucleus, they have higher energy. We learn in Bohr's atomic theory. Basha? Let's talk about angular momentum quantum number. Angular momentum quantum numbers, they what? They show sublevels. We know that we have S, P, D, F sublevels. So these quantum numbers, they describe these sublevels. They're going to be symbolized by L. Basha, small l. L has 4 numbers. Basha. When L equals 0, when L equals 1, when L equals 2, when L equals 3. When L equals 0 shows what? S sublevel. Basha, S sublevel. When L equals 1, P sublevel. When L equals 2, D sublevel. When L equals 3, F sublevel. Basha, let's talk about the shape of the sublevels or orbitals, shape of orbitals in sublevels. Guys, when electrons, they spin around the nucleus, they make different shapes. Basha, they make different shapes. We have 3D. Basha, when electrons, for example, electrons in s orbital, when they move, look, at the end, they get a shape. Basha, the shape is spherical. Okay, this is the s orbitals. It means the s sublevel orbitals. The electrons, they make this shape, which is called spherical shape. Basha, so s orbitals, they have spherical shape. And electrons in p orbitals, they what? They have dumbbell shape. Look, they have dumbbell shape. So p orbitals, and it means electrons in p orbitals. And d orbital, more complex. F orbitals, even more complex. Basha, this is written here. Okay, so angular momentum quantum number describe these sublevels. Basha, when we say, so S sublevel, L equals 0. L is angular momentum quantum number. Basha, so when L equals 1, P sublevel describe P sublevel, L equals 2, D sublevel, L equals 3, F sublevels, and know the shape of the sublevels orbitals. Basha, so we want to know the number of sublevels in each main energy level. We talked about, we said that first energy level we have only one, only S, second S and P. So we say that total number of possible sublevels in main energy level equals number of N. Basha. When N equals 1, we have only one sublevel, which is S. When N equals 2, we have 2 sublevels. Number of sublevels equals the number of N. S and P. N equals 3, SPD. N equals 4, SPD, F. We learned that. So we're going to give them what? Number. We know that S sublevel describes by 0. And its angular momentum quantum number equals 0. Basha, value of L. For SP, S0 and P1. So possible numbers, they are 0 and 1. For N equals 3, we have SPD S0. P sublevel describes by 1. And D describes by 2. Also for S, PDF 0, 1, 2, 3. 3 is for F sublevel. Okay. Magnetic quantum number. Magnetic quantum number symbolized by M, Basha. Magnetic quantum number describe the orbitals. What of the orbitals? The orientation of the orbital. So shows what? The orientation of the orbital, or in other words, we can say the axis. So what axis the orbital is on? Magnetic quantum number is going to explain. Basha. Value of magnetic quantum number M equals minus L2, or we can say negative L2, positive L. Basha. Look, we know that for L, Basha, for L, when L equals 0, describe the S sublevel. S sublevel contains only one orbital, which is S. We can say S orbital. So P contains P sublevel. When L equals 1, means describe the P sublevel. There are 3 orbitals. D, when L equals 2, we have 5. F, we have 7 orbitals and describes by 3. L, angular momentum quantum number equals 3 for F sublevel. Bash. Let's number the orbitals. For S, we say that the magnetic quantum number, why it's 0? Because minus L, 0. 2, positive L. So minus L, we don't have minus 0 plus 0. This is still 0. Basha. So for S sublevel, S orbital, we give what? We have, we give 0. Basha. P sublevels, we have 3 orbitals. So for, we start from minus L to positive L. So minus L from left to positive L from right. So between these we have 0. Bash. These are how we number the orbitals of sublevel. Bash. When for the S orbital, look, we don't have a specific axis for the S orbitals when they spin around the nucleus. It's like that. Bash. For P orbitals, the one that spins in the x-axis, look at here, px. We called what? Px means the electrons in this orbital spins in what? On what? On x-axis. Basha. Py means Py orbital spins on y-axis. Pz orbital spins on what? On z-axis. We call Pz. Basha. We give it positive 1. The one that spins Pz, we were going to give positive 1. Its magnetic quantum number equals positive 1. Basha. For d orbitals, we start from minus 2. Why? Because the rule says from minus L to positive L. Basha. Between these we have minus 2, minus 1, 0, plus 1, and plus 2. Okay. So dxy means the orbital that spins on x and y, look, axis, we call dxy orbital. We give minus 2. It's magnetic quantum number. We can say we describe this orbital by minus 2. It's m equals minus 2. Basha. Here, this orbital, the orbital dxy, why you say dxy means this orbital spins on y and z axis. Basha. So its magnetic quantum number equals minus 1. And so on. This is like that. Basha. For F, we don't gain to number it here. We don't describe on which axis. The the electrons in this orbital, in these orbitals, they are going to spin around the nucleus. Basha, just know this, okay? And for the z squared, guys, look, its shape is not like the shape of other orbitals. It's different, this one, Basha. Okay. Spin quantum number, they describe the electrons in the orbitals. What of the electrons? Spin states. So symbolized by ms, Basha, shows the two spin states of an electron in an orbital. Basha, ms can be either positive 1 over 2, negative 1 over 2. Guys, electrons, they're like that. In each orbital, we know we have two electrons. One of them spins clockwise, the other one anti-clockwise. Okay, we have clockwise spin, anti-clockwise spin. Basha, when ms equals positive 1 over 2, we say clockwise spin. Means the electron that spins clockwise, we're going to give a number which is positive 1 over 2. Basha, so for anti-clockwise spin, ms equals what? Negative 1 over 2. Okay? These are the four quantum numbers. They describe the orbitals, sublevels, energy levels, and spin states of the electrons. Okay? This is the section review and the answers. Okay, inshallah, next time we will talk about chapter 4, section 3, electron configuration. Okay, thank you for listening. See you.